Okay, so let's continue in shear and beams. So this time is mag-solve tayo ng maximum spacing of 10 mm diameter stirrups at critical section of the beam. Okay? So given yung following data ng rectangular beam, so yung beam width natin is 250 mm and then yung effective depth natin is 450 mm. So yung simple span natin, simply supported beam pala siya. So yung length niya is 8 meter. And then meron tayo ditong mga service load for dead load. So for dead load, we have 28 kN meter, that is including yung beam weight. And then yung live load natin is meron tayong 35 kN per meter. So yung stirrups natin is, yung diameter niya is 10 mm diameter. Yung yield stress niya is 275 megapascal. And for the concrete, yung FC prime niya is 21 megapascal. Okay? So determine yung maximum spacing of 10 mm diameter stirrups at critical section on the beam using yung 3 legs of stirrup. So parang ganito yung itsura niya. Okay, so kung meron tayong stirrup na ganyan, so meron pa siya dito, 3-legged siya, no? Okay. So bali meron tayo dito ganyan, I don't know, siguro ganito, stirrups naman din yung gusto ko, no? Ayan, 3-legged yung ano natin. Okay. So, solve natin to. So, meron tayong simple span. And then, meron tayo ditong load, no? So, meron siyang in-apply dito na load. Yung W. So gamitin ko lang 2010 or 2015. So yung 1.2 nung dead load plus 1.6 nung live load. So we have 1.2. Yung dead load natin is 28. And then I have 1.6 and then yung live load natin is 35. So therefore meron tayong ilan to? 1.2 times 28 plus 1.6 times 35. So we have 89.6. 89.6 kilonewton meter. So yung length na to is 8 meter. So, gawa muna ako dito ng project muna yung line na to. And then, gawa ko ng shear diagram. So, since simply supported to, so alam natin na kunin ko muna yung reaction. So, yung reaction dito, if I assume this is point A and this point B, so meron akong reaction at point A and meron akong reaction at point B, no? So since symmetrical, so pareho lang yung reaction nila, no? Both sides. Okay, so by symmetry, yung RA is just equals to RB equals to R. Assume ko na lang na R. So, yung R is just yung WU times yung length natin divided by 2, no? Yung total load divided by 2. So, we have 89.6 times yung length na 8 divided by 2. So, therefore, meron tayong 89.6 times 8 divided by 2. So we have 358.4. So, 358.4 kilonewton. So, yan, no? So, meron tayong 358.4 kilonewton. So, siya mo na lang dito yan. So, ito yung 358.4 kilonewton. Ganun din dito sa kabilang side is negative 358.4 kilonewton. So, connect ko lang yan. Okay. So, connect ko din to. Connect ko din to. Ayan. So, ito na yung shear diagram natin. So, kunin ko lang yung shear dito sa critical section. Okay. So, ito yung critical section niya. No? Kasi, yan din yung tanong eh. At critical section. So, that is at distance D, no? Or yung effective depth. So, yung effective depth natin, that is 0.45. So, we have 0.45. Okay? So, ilan to? Ha? So, if I assume this is Y, no? And ito length L divided by 2. Alam natin yan, no? Kasi ito center line, no? So, this is 8 divided by 2. So, we have 4 meter. So, ibig sabihin yung natira dito, if I assume this is Z, so that is just 4 minus 0.45. Or yung Z natin is just equal to, ilan yan? Ayoko na mag-isip eh, no? 3.55. So, we have 3.55 So, by ratio and proportion, so Y over Z is just equal to yung 358.4 all over yung length na 4. Or we have Y all over yung Z natin na 3.55 is just equal to 358.4 all over 4. So, yung Y natin is just equal to, yung Y natin yan din yung VU. No? So, that is also equal to VU. So, meron na tayong design na value na shear strength. So, 3.55 and this one is 358.4 all over 4 ship solve. So, 318.08. So, we have 318.08 kilonewton. So, ito na yung gagamitin natin, no? Ito na yung design shear strength. Okay? So, there is also another way in solving for the design shear strength, which is mas madali siya, no? Kaysa ng ratio and proportion. So, consider mo lang to. Diba? Kukunin ko lang yan. So, mas madali pag ganito eh. No? Another way, another solution is yung RA natin, nakuha na natin to. This is 358.4 kilonewton and then yung W natin, solve na din natin to. That is 89.6 kilonewton meter. Okay, so yung gusto nating makuha is yung distance dito, no? Yung shear at that distance na D, which is 0.45 meter. So this is 0.45 meter. So yung gagawin lang natin is putulan lang natin yan, no? So bali consider na lang natin yung dito na lang na part, yung dyan lang, no? So bali parang ito yan. So consider natin yan. And then meron tayo ditong bali dito yung cutting natin, ha? So ito yung RA na 358.4 kilonewton, and then dito meron tayong 89.6 kilonewton meter, and then yung distance nito is 0.45 meter. Okay, so pwede natin makuha yung shear na dito, ha? So yung shear dyan is just, yun din yung VU. So we have RA minus yung WU, ito yan, times yung distance na D. Okay, or yung VU natin is just 358.4 minus 89.6 times 0.45, or yung VU natin is just equal to 358.4 minus 89.6 times 0.45. So we have 318.08. So mas madali pag ganito yung way mo. So ganito na lang yung gagamitin natin, ha. Pag nakukompute kayo, ganito na lang din yung gamitin nyo. Mas madali kasi. Okay? So the same value. So yung issue natin is maximum spacing ng stirrup. So next kong gagawin is kukunin ko yung value nung VU. Okay? Tapos na yung VU, yung VC na naman. So compute natin yung VC. That is just equal to 0.17 square root ng FC prime BW times yung depth. Ito is always 1. Pero may ano yan, may value yan sa NSCP. Pero pag nagdi-design tayo ng stirrup, laging 1 yan. So we have 0.17 times 1 square root nung 21, and then yung ito 21, and then yan 250 tsaka 450. So we have 250 times 450. So you take note, naka mm to tsaka megapascal. So divide ko na lang to ng 1000 para yung sagot ko automatic kilonewton, para diretso ko mamaya. So I have 0.17 times 1 square root ng 21 times 250 times 450. Okay? Then yan lahat divide ko na lang ng 1000. So we have 87.64 kilonewton. 87.64 kilonewton. Next is yung VS. So compute natin yung value ng VS. So from the formula na VU equals VVC plus VVS. So makukompute ko na yung value ng VS. Yung VU natin is 318.08, and then yung V natin pag 2010 or 2015, 0.75. So 0.75, yung VC natin is 87.64 plus yung 0.75 nung VS. Okay? Or pwede nating sabihin na it's just equal to 87.64 plus the VS. So solve natin yung VS. So we have now the value of VS. We have 318.08 alpha equal 0.75. Yung VC natin is 87.64 And then plus yung alpha x, yan yung VS natin. So we have 336.47. So this is 336.47 kilonewton. And we're going to check if less than siya. So check if section is adequate to carry yung shear. So, ganun, no? So, check lang natin to. So, ilan kaya ito? So, check lang natin yung VS. Dapat less than siya or equal nung 0.66. Diba? 66. Ito. Pero sa, this is 2001. Pero sa 2010 or 2015, 0.67 yung gagamitin. Okay? Sa 2001 is 0.66. So, 0.67 yung gagamitin ko. So, we have 0.67 square root nung FC prime BW times D. Depth. Ilan kaya ito? 0.67 square root nung 21 times 250 times 450 divided by 1,000. So, ilan yan? Check ko muna. Divide ko na ng 1,000 para automatic yung sagot ko. 0.67 square root ng 21 times 250 times 450. Lahat yan. Divide natin ng 1,000. So, we have 345.41. 345.41. So, 345.41 kilonewton. So, check natin kung okay siya, na? Yung VS natin is 336.47. Ayan. So, this is okay. No? So, if yung VS natin is greater than 0.67 square root ng FC prime BWD, so, we need to adjust yung beam size. If ever na nangyari na ganito. Pero sa case na to, hindi siya nangyari. So, okay na yan. Okay yung section. So far, nakuha na natin yung value ng VC, yung VS, and VU. So, I think, pwede na tayo mag-solve ng spacing. Okay? So, yung stress for stirrup is just equal to the force of stirrup, which is yun yung shear, divided by yung area nung mag-shear total. Okay? So, yung stress ng stirrup is FYT. And then we have the VS. And then we have the number of A times V. No? Okay? And then yung N natin, that is VS. That is just yung effective depth divided by yung spacing ng stirrup. And then we have the EV. Okay, so makikita natin dito na 3 legs yung ano natin, no? So 3 legs yan. And then ko lang yan dito, ha. So 3 legs siya, no? Pag alam naman natin na yung beam, pag ikakating natin yan, magka-crack yan, ha? So may mga stirrups yan, ha? So yung cross section yan is ito yan, no? So ibig sabihin kinakat nito, ha? Kinakat niya to. Kinakat niyan. So isang cut lahat yan, no? So ito yung area ng EV. So, yung EV dyan natin bisa 3 legs is 3 times nung pi over 4 diameter ng stirrup squared. So meron tayong 3 times nung pi over 4. And alam natin yung diameter ng stirrup is given 10 millimeter. So therefore we have 10 squared. So substitute ko na lang lahat, no? So yung FYT natin is also given. So 275. Okay. So we have 275. Dito is spacing of stirrups yung kinocompute natin, ha? So 275 megapascal. And then yung VS natin, na-compute natin yan, that is 336.47. So we have 336.47. So times ko ng 1,000 para maging Newton lahat to. Di ba? Kasi naka-megapascal ako yun. Expected dapat Newton ako lahat. Newton tsaka mm. And then yung effective depth natin, that is also given. We have 450. Ito yung tanong, yung spacing. Di ba? And then yung EV natin is meron tayong 3 times nung pi over 4 10 squared. So yung spacing natin, which is ito yung tinatanong, is masasolve na natin yan. So we have tingnan ko muna, 275 alpha equal nung 336.47 times 1,000 all over yung 450 divided by yung spacing, which is yung x, and then meron tayong tatlong 3-legged, no? So 3 pi over 4 times yung 10 squared. Should solve. So we have the spacing of 86.66. Okay? So 86.66 mm. Okay. So yan, no? So pwede rin kung ayaw mo ng ganito, parang medyo yung approach ko kasi dito is parang strength of materials. Pwede din yung formula ng spacing for stirrups, no? Which is derived pa rin dito, no? So, mas madali yan, actually. Mas madali yan. Kasi, direct substitution ka na, no? So, pwede rin gamitin yung formula na EV, FYT, D all over yung VS. Same pa rin yan. So, meron kang tatlong tag pi over 4, 10 squared. Yan yung sa EV. Yung FYT mo is 275. And then, meron kang 450. And then, meron kang VS na 336.47 times 10 to the power 3 or 1,000. So, yung spacing mo is 86.65 mm. Okay? So, ganun. No? So, ganun lang. So, okay na yung spacing natin. Next natin kukunin is, so, dito is, yung kinocompute natin is value of VC. Okay, okay na yan. Punta tayo dito sa maximum spacing. Maximum spacing of stirrups. Okay, so kunin ko lang yung twice ng VC. So, 2 times yung VC natin, that is 87.64. 87.64. So therefore I have 2 times 87.64, 175.28. 175.28 kilonewton. And then yung VS natin, that is 336.47. 336.47. So kung ito yung graph natin for the VS, so yung twice ng VC, ito yan, twice ng VC, that is 175.28. Okay, so greater than siya, no? Greater than siya ng twice ng BC. So, yung VS natin is andito banda. 336.47. Pero i-check natin yan. Baka against yan ng code. No? Ilan yung 4 BC? So, 4 times 87.64. So, we have palitan ko lang ito ng 350.56. So, 4 BC is 350.46. So, in between siya nung so walang problema. So, pag dito ka banda, di ba? Alam ko na, dito siya no? So, ito yung not allowed sa code. Dito, di ba? Kung babalikan natin yung formula. Ito, no? So, ito yung gagamitin natin, no? Itong formula na to. So, check lang natin yan. Yan na yan. So, bali dito, meron akong ganyan, no? Okay. So, pili tayo dito. Smallest value. Okay? So, yung D over 4, that is 450 divided by 4. So, that is 112.5 mm. Okay? And number 2, we have 300 mm. And then, number 3 is yung kinumpute natin na spacing. We have 86.5. 65. So, smallest value of this one. So, ito yung mag-govern. Okay, so we have 86.65. Okay. So, yun yung mag-govern sa design. No? Take note, yung spacing is always round down. And mas maganda pag mas maliit yung spacing. Mas safe. No? Kaysa yung mas malaki yung spacing. So, I hope may natutunan kayo dito sa pag-design ng stirrup for beam. So, review nyo lang yung first na video dito para makita nyo yung mga formulas tsaka yung mga code and mga limits na kailangan. Sige, so thank you and see you in the next video.